Okay, today what we're going to do is to show how to set up the DVT40 probe so that we can measure pads on a test board. And we have a portion of a dual probing system here. We've got a manipulator, the DVT FP60, attached to the DVT40 probe, and we have a test board with some test pads. So in order to make it easy to set the system up, what we did was we attached the probe to the end of the manipulator to this adapter. And then we placed it so it's almost vertical to the test pad. So we do this because we have a ground collar on the end of the probe that has compliant Pogo-pins in it. And those Pogo-pins have to be almost vertical to the test pad so that when they're making contact with the pads, that there's a little ground pin that slides into a sleeve, and we'll show you that later on. Now, to establish the distance between the probe and the base, we've set this up so that the probe is attached, and we put it down on the base down onto the metal plate. Now, what we want to do is to establish that the base and the boards are parallel to each other. So what we did was we used a square so that we line up the edge of the base to it, which is now parallel to the metal plate. And then to mark it, we put a piece of tape. Now we do the same thing to the other side, and now this board is now parallel to this base, and it's also squared to the metal plate. And we put a piece of tape there in case we want to put these, move these and put these back in the same positions. Okay, so the next thing we're going to do is we're going to remove this protective sleeve that you want to use when you're setting up your probe so that we can see the probe tips. And what we're going to do is to set up a camera so we can planarize and verify that the ground pins are set in the right position so their tips slide into the sleeve. So to the right here we have a camera system, a very flexible camera system, and we have just described a couple of pieces on here. This is its adapter that it slides into, and it has a fine-tuned X control, and then there's a theta control here, and then this arm here is adjustable, and then once you have it in place you tighten this knob and the camera will stay in that position. Then for controls and fine-tuning controls, we have the XYZ controls here and a magnetic base. Now we don't have to set this thing up to precisely have it parallel to the board, because this arm is going to be moving around until we get the probe tips in view. Now what we want to do here is to twist this in its adapters so that on the display the pads and traces will be running vertical down on the display, so that above it you'll see the probes coming down. So the probes will be coming down here and making contact, and by establishing it in this position it's easier to kind of visualize how the probes will be set up. So now that we have our probe over our test pads, what we want to do is use the manipulator's X, Y, and Z controls to adjust the probe so the probe tips making contact with the test pads, as well as having our ground pin making contact as well. So as I turn this X-axis, the probes will come down onto the test pads, and the first thing that makes contact is the ground pin that's on the left-hand side. What you want to do, I'll bring this back up again so that you can see it. You can see the silver pin that needs to be sliding into its sleeve. If it doesn't slide into the sleeve, it will bend and damage the ground. So If it doesn't, the way what you want to do is to adjust the probe so it's more vertical and retest it like this to make sure that the sleeve, the probe tip is in the sleeve. Okay, now that we've adjusted our probe to put it in on the test pads, then what we want to do is verify that both probe tips are making contact with the test pads. One little trick I've found kind of effective at locating and determining whether they're planar is I just put my finger just a little bit behind the two differential connectors, and I just wiggle my finger back and forth, and I watch the probes in the display. If the probe isn't making contact, what happens is it kind of wiggles back and forth. The other one will pivot back and forth. The one that's wiggling is not making contact, nor will it be making electrical contact. So what we want to do is adjust our theta and Y controls in order to bring the probe tip to make a contact with the test pads. So both probe tips are equally making contact. That way they're planar to the test pads. So to planarize the two probes so they're both making contact, what I'm going to do is I'm going to bring up the probe with the x-axis, and then I'm going to adjust the theta control and move the theta control so that it rocks it planar, and then I'm going to use the Y control to bring it back. Now on the display, what it's going to look like is that when I adjust this, it's just going to move it to the right, and it's actually more rocking it and then planarizing it outside where the test pads are, and then we're bringing it back. Hopefully it's then planar and dropping it down using our X controls. So first thing you want to do then is bring up the probe tips, so both the probe tips and the ground clear the test pads. Next thing I want to do is, since this one here is the one that's not making contact, I want to move it off to this direction, so I move this side down. And I do that by adjusting the theta control. Okay. Now, we assume that has moved that down so it's planar, and we're going to use the Y control to move the probe tips back over the test pads, and then we're going to use our Z controls in order to bring them back down. Now I'm going to put my finger back between the two connectors. I'm going to wiggle it back and forth. Okay, and then check to make sure that the pads, both of them, are now going to pivot off the probe. So as I move this, you can see them pivoting, but they're not shaking or wiggling off the pads. So now we've got these planar. Now with the probe raised over the test pads, before you probe, take some alcohol on a swab and swab the test pads to get any oxide. Also check for resin. A lot of prototypes have resin still on them, which are very difficult and impossible to probe through. This will assure an excellent measurement. Okay, the next thing I want to do is I want to show you how to replace the Pogo-pin. It's a half OD Pogo-pin. It's easily damaged, especially if you don't get it established correctly vertically, and the pin is bent. Or if the pin hits something, it can also bend and it won't be able to put the pin back into the sleeve. So what we want to do is we're going to bring this probe up to clear the test pads we just put it on. And I'm going to just swing this around like this so I can get access to the probe end of it. And I'm going to bring it up like this so it's going to be easy to work with. And you can't see it from this angle, but there's a very small screw. It's a compression screw on the other side of the ground collar. So I'm going to hold it with one hand, and this screwdriver comes with the kit. So I'm going to loosen the screw, and then I'm going to take and put the screwdriver kind of behind it and gently push each side so it slides off and exposing the probe with the two probe tips. And you want to hold it so it's down like this with the probe end down. Otherwise, if I turn it like this too much, the probe will actually slide out and fall on the ground and you'll lose it. So I want to show you that we have two different kinds of ground collars. First of all, this ground collar can accept 3 pins, and these pins are placed from the back forward. So here's 3 different holes that you can put a ground pin. And I generally just use one ground pin. If you put in more than that, it gets a little difficult to set up, but it seemed to do a fairly good job electrically. So this is an inline or an L collar. This one here, if the signal pins and the ground pins are one's behind the other, then what you want to do is use this one here. This has the 2 ground pins that you can put in here, and the probe tips would come out here. So that places the ground pins directly behind the signal pins. I find a lot of packages for processors or high-speed FPGAs, for some reason they put the ground pins directly behind the signal pins, and it's almost impossible with a single probe to make a measurement differentially. But with this ground collar, then it places it in a proper position to gain access to your ground. Okay, now that we've removed the ground collar from the end of the DVT40 probe, I'm just going to place it on the screwdriver that comes with the kit that's used to tighten the screw that closes this gap around the body of the probe to hold it in place. We're doing this just so that it's easier to film. So you use the tweezers that come with the kit to grab the head of the pin, and then you pull it out and then replace it, and then you go ahead and attach it to the body of the probe. Tighten the screw, and you're back in business.